Yeah, so organic chemistry next fall, you're going to kind of start out with reviewing, hybridization, geometry, bond angles, functional groups, chirality. So this will be kind of a review for that. Even though we did this in Chem 106, it's also important to understand as we're talking about these functional groups. So which of the following compounds do not contain an sp3 hybridized oxygen atom? So if we look at a ketone, right, a ketone, I want the pen back, right? Ketone, we've got a carbon oxygen double bond, right? An alcohol, we've got carbon, oxygen, hydrogen. An ether, right? We've got carbon, oxygen, carbon. Ester, we have carbon, oxygen double bond, right, an oxygen, and then a carbon. All right, I'll make all of these full functional groups, and then water. So we should know the hybridization of carbon, right? If carbon has 4 substituents, right, we are sp3 hybridized. So like this carbon, I've got 3 branches to hydrogen, 1 bond to oxygen, so 4 bonds, right? That carbon in ether is sp3 hybridized, which makes the oxygen also sp3 hybridized. So sp3, sp3, right, sp3. Same thing up here. We're sp3 hybridized because I've got 4 electron domains on that oxygen, right? I've got 1 bonding domain, 2 bonding domains, and then 2 non-bonding domains. So 4 domains, that oxygen is sp3 hybridized. Down here in the ester, same thing. I've got 2 bonding domains, 2 non-bonding domains. That's 4 domains. So that oxygen is also sp3 hybridized. To be sp2 hybridized, right, you just need 3 domains. So this carbon right here is sp2 hybridized because it has 1, 2, 3 domains. That oxygen is also sp2 hybridized because it also has 3 domains only. It's got the carbon-oxygen double bond, which is 1 domain, and then 2 lone pairs of electrons. So that's 3 domains. So that would make this oxygen sp2 hybridized. That's the only way it's able to form a double bond. So if you see an oxygen attached to a carbon double bond, it has to be sp2 hybridized. So the only compound that does not contain an sp3 hybridized oxygen atom would be this ketone, because my only oxygen here is sp2 hybridized. In the alcohol, sp3. In the ether, sp3. In the ester, I have both. I have an sp3 down here. I have an sp2 up here, right? But because we have the one sp3 hybridized here, and then same thing here. I've got 4 electron domains in oxygen and water. So that oxygen and water is also sp3 hybridized. So the ketone functional group is the only one that does not contain an sp3 hybridized oxygen. It's sp2. Any questions on that? All right. What else do we want to take a look at on the practice exam?